To graph a linear inequality, like this one I have on the screen, you actually can start by thinking of it as an equation instead of an inequality. So you got an equal symbol. Okay, I mean it's obviously not the same thing as an equation. We'll go back and we'll take care of the inequality symbol at the end. So graph it like you would a normal equation, where the y-intercept is the number hanging out by itself. Because look, this is in slope-intercept. So the y-intercept, the starting dot, is at 3. So I'm going to put a dot on 3 on the y-axis. That's why we call it the y-intercept. Oops. And then we have a slope. The slope is the number that's attached here, so we can write a 1 in its place. That's the slope. Or you can always take like a slope that's a plain old number and turn it into a fraction by dividing it by 1. If the slope is 1, that's the same thing as 1 over 1, right? That's helpful because a slope helps us determine the rise over the run. This means we rise 1 point from our starting dot. So I put that extra hash mark to go up 1. And then we go to the right 1 point and put a dot. Okay? And now if we had a negative 1 for a slope, that would be a negative rise, which means we just go down 1 into the right 1 instead. Okay, but we got a positive 1, that means we go up 1 into the right 1, we put a dot. And you could do another dot by going up 1 to the right 1 again, but 2 dots are enough to make a line. Okay, so now we have an idea of where the line is. We're going to actually erase that solid line and put a dotted line like this. And the reason is because a solution is not on the line. A solution would be on the line. If this said y is less than or equal to x plus 3, the or equal to part means the solution could be directly on the line. We would use a solid line. But since this isn't here, we're going to use a dotted line going diagonally like this. And now the last part we need for an inequality is the solution is either over here or over here. There's an infinite amount of pairs that would make this become a true statement. They're all either on this side or on this side of the graph. So to figure out which side, you just pick a test point. You can pick whatever point you want. Like maybe this is -2, 5. You could plug that in and see if it makes a true statement. Plug in 5 for y and -2 for x. And is that true? Is 5 less than 1? Because that's what this simplifies to be. 5 isn't less than 1, right? 5 is greater than 1. We plugged in this point into this inequality. It was false. You could try another one and be false on this side. So this is our solution. So that's where we need to shade.